Hello, hello. We're going to try a different microphone. Actually, it's an old microphone, but everything old is new again. We're going to front light instead of just backlight. Time for me to get a new head shave. Time for me to get a new head shave. Oh, I got to get my chat going. Hold on. I forgot that important part. There are people sending all these messages that I cannot yet see because of the chat. Okay, now I'm on the chat. That's good. Okay, so I have this problem. It only happens on Linux. It is not a compiler bug like I was debugging recently. It is this one test fails intermittently. And looking at the code, my suspicion is that this wait for thread doesn't actually work. Either it never worked and I lucked out on different systems that had different multi-thread timings, right? Or I broke it. So I want to look at what wait for thread does on Linux, except thread is done is what it's called. Okay. Okay, that doesn't wait for a thread though. Who did that? That okay, whoever adapted this demo didn't. Might have been me who did this, but I don't think so. So now what's interesting is it fails in both backends, which makes me kind of know that it really is a logic bug. Yeah, I would believe that just the slowness of WSP or whatever the hell this is that we're using um, makes it makes the timing different. I mean, now it's working. Hello. Oh, wait, now it doesn't work. See, that's so very funny. Why did it work until it didn't? Oh, maybe I can't. Maybe it's seg faulting and it's not saying. I don't know. Let me add more info. See what happens there. Oh, oh, I'm not edit. Okay, I'm not editing this on the Linux system for Win. This is the wrong file. This is the wrong file, guys. I hope everybody knew that. What was this one? No, bro. It's now going to take me. Hit enter too early, so now we're suffering the WSL $$ slowness penalty to open the wrong file, which isn't executable. And now we have to take that penalty again. Maybe Casey did not write that code. Is there even still someone to fire? Probably not. Probably not. I've got a massive bottle of water for core hydration. All right. So we're serious. We're serious. Okay, wait for thread. Now is it different? Ha, it doesn't even compile. So we have to remember to revert that. Okay, so we're editing the other one. Wait for thread. Okay. Oh. See, I was dumb. This is a 32. Wait for thread returs. I didn't even spell that right. Um, no. Is it just called index? Is it called, whoops, is it called thread index? Ha ha. Lol. Oh, because we delete the frickin' thread. Okay, whatever. No, that's not why. So the bug is still happening, is really what we're saying. Okay, this is interesting. it's not like this might actually be a compiler bug because I built it once and then it fails every time. And then I built it again and it succeeds every time with the same arguments of building. Okay, is WSL broken with regard to POSIX thread stuff in some way? If it were, but then that wouldn't lead to this kind of situation. I think there's a compiler bug. Binary compare executables. Um, I'm not sure if that's the best way to do it because I'm not sure what I would do. Like the thing is, we don't do 100% reproducible builds right now because the order in which threads retire stuff determines the order in which we get to it, which determines the order it's in the file. And sorting that is slower, which we could do that. Um, I mean, we could do it as a debug thing, but it's like that's not in there right now, right? So that would be a whole situation. In fact, there's also like there's like a date stamp in the executable file that we actually set, which we probably shouldn't. I think WSL1 had issues with this. Really? Go back to VirtualBox. Well, I don't have VirtualBox set up in a way that works right now. Um, okay. Since I don't know if this is a problem, and it only happens on Linux, I am just going to leave this change in like this. But it can't, no, it can't. It can't be a WSL problem. Um, unless it's actually a problem about inconsistently linking your program against the wrong thing, which actually, I wouldn't put that past Microsoft at all. Hmm. I do kind of want to know. Let's continue to look at this and see if it starts to make more sense or not. Uh, yeah, like, okay, wait, how is this? Oh, that's the Windows one, probably. That back. Yeah, that's like, no, that's Linux. Oh, I'm editing the wrong file again, everybody. Let's wait 30 seconds for that to load. What is the issue at hand? There is one of the tests seems to fail only on Linux. And it may have to do with the little thread library code for Linux, which I didn't write. So I will be investigating this. Or all right. So this time it works fine. So when it's crashing, I think it's asserting that the index is not 0, and it is. So let's try compiling it and see if we get crash version. Oh no, it's okay. Whoops. Let's just see where it's crashing. Because I thought it was there, but it might be somewhere else. Atomic add. How do you print locals? Info locals. Okay, so I guess the x64 debug info on Linux does not give locals right now for some reason. That's not great. But this crash also happens with the LLVM backend. So I'm just going to keep compiling it until we get the crash version again. If that ever happens with LLVM. There we go. Very weird. Very weird. And then once it crashes, it always crashes. So that could be, this feels like a significant compiler bug to me. Print thread. So atomic add is seg faulting. Is that a WSL problem? Because next thread index is a frickin' global. The weird thing is on both backends, this probably generates different output. Because for LLVM, we say like, hey, make this weird high-level atomic ting-tangler, right? I'm not sure. I guess we can disassemble, right? Like, where did it crash? Where's the program counter? There it is. Yeah, dude. Wait, what? Okay, that's my fault then. So either the address patching is bad or something else is bad. It's got a really big offset from a global variable. So this is actually kind of like what was happening last time we streamed, except most of the problems are fixed now. But this one isn't. Except no, this can't be an x64 backend bug. It can't be an address patching bug because this is the LLVM output, and that other stuff doesn't even run. So this is the global address of this variable is getting corrupted like way early, but only sometimes, and it depends on compilation order. So Question, does this happen with no jobs? And why doesn't it happen on Windows? That's very weird. Maybe it does, and I just didn't notice it somehow. Okay. Okay, that's good. The no jobs version crashes, which is great. Um, the no jobs LLVM version crashes, but not X. Oh, maybe it doesn't matter. Woof. Okay, that's bad. That's very bad. This is very bad. Come on, guys. Wait, if I say dash LLVM, let's try it not. Now it's just refusing to happen. We warmed up the CPUs, everybody. The CPUs are warm, so it doesn't happen anymore. It probably really is something to do with it, by the way. Why didn't I buy a giant bag of peanut M&Ms today? All I have is Sun Chips. The loser gets to waste time. Yeah, basically. The loser gets to waste time. I don't think it's a WSL problem. Unless it is. Maybe that was the right address for the variable, actually. I should have printed it out. Let's see if we can get it to happen again. Okay, so the installation manual for the compiler beta is going to say, just run the compiler 37 times by hand on this example, and then it'll stop crashing. And then you're good. Oh, wait, that would be if this was a Linux program. Oh, wait, it is a Linux program. Lol. There we go. All right, we're just going to run it again, let it crash. Now, print address of next thread index. print RSP. Wait, info. No. Was it stack pointer or? So it's saying 255,000 from RAX. So what we want to know is that correct? Maybe this address is correct, in which case the lock is crashing somehow. Or maybe this address is wrong, which is what I think is actually happening. I think the address is bogus. Because that, if the address gets generated bogusly, but only sometimes, that explains why this happens 100% of the time per compile, right? If it's a mistake that happens during compilation. Okay. Is there a way that I can say RAX by name as a value for printing? I tried %RAX before and that doesn't work. Plus OX255000. Wait, the address of next thread index is this. Wait, so this, um, what? Okay, what's my theory for this? My theory for this is I honestly don't have one. Is this, am I reading the syntax correctly? I forget how to change the syntax. I don't want info registers RAX. I want to use it as a value so I can say print RAX plus whatever. You guess I could try thread sand? No, that's not remotely going to help with this. No, 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 no. $RAX, okay. It's weird that it prints it as percent here, but it's $, whatever. How do I change to Intel syntax? Set disassembly flavor Intel. Okay. Okay. Lock add RAX plus big ass number ECX, right? And RAX is a big ass number. But what we think is the address of this variable is that same number. Like what? Okay. Now what's weird is, so this global database is just a variable that we alias to the start of that data section. So this thinks that the address of this variable is at offset 0 from the section, which it might legitimately be, but might not. Now, the thing is, if this were wrong, I would expect accessing it to crash us, except we're not accessing this. We're accessing this plus RAX. Wait, is this actually what this means? Is this the full address, or is this like an offset from that? Like, what if I go print? Yeah, how do I print in hex? Dude, why am I even trying right now? God, no, fuck you. I'm not even going there. Oh, this is a GDB command. This is not function evaluation? Like this? Okay. Okay, so 255,000, which is this. So this is the actual address of the actual symbol. What I am not able yet to make a theory for in my own mind is how I get the patching wrong for this in both backends, and only sometimes. That is very weird. Okay, I think multiple things are happening wrong. Because this thing, I don't know. Problem is because this is LLVM output. I don't know what's going on here. I would like to see the x64 output crash as well, if we can get that to happen. Ever again. There we go. See, the CPU cooled down. Whoops, run. Ugh. Damn it, bro. Set disassembly flavor Intel. All right. See, we're learning. Okay, there we are. Okay, print. Oh, but I probably don't have the variable here because something's broken. Okay. I'm going to go out on a limb and say that that is probably not a valid address. Probably. I mean, I don't know everything about these newfangled computers, but that is probably not a valid user space 64-bit address. It's just a theory. It's just a theory. So that means that when I output that, well, I mean, the thing is it invalid because of address patching or is it invalid before address patching? Okay, what was this variable? Print next thread index. 27B1000. It's still the first thing in global database. Honestly, that's a little bit fishy because I would expect other things to be first. I can do something really stupid to guarantee it's not first. Do you want to see real stupidity? Here we go. I'm going to say S is a struct with buff for no check-in is 512 U8s, and then this using that. I mean, that's even more verbose than we had to be. Now the question is, does that for some reason prevent the crash from happening? Who knows? Because sometimes we have to run this 20 bazillion times. Come on, bro. Don't at me. All right, we're going to let the computer cool down. Does that mean that this version of the compiler randomly adds RAX to the dereferencing operation? No, it doesn't mean that, because first of all, that's inconsistent between the backends, and secondly, that is below the level at which we interface with the backends. So it simply cannot be what's happening. I mean, like never say never, but it's very hard to imagine how that would go. All right, well, maybe this has to do with it being address 0. Or actually putting it inside a struct with a using does completely change the timing with respect to out of order ting-tanglers. All right, so I feel like this is working around the bug in some way. So we're going to undo this. That has a no check-in in it. Okay, yeah. So next, well, when I generate this instruction, we can certainly print out what is this? This is atomic add. There we go. Report info see, debug expression, atomic add. Um, see, we already loaded the register. That's the thing. Ugh. Woof. Okay, wait. Do we still have a crash? Hold on. So remember we loaded RDI. Wait, it's totally different now. Like, squeeze me. Baking powder. What is RIZ? I've seen this before. Is that like supposed to be the carry bit or something? Wait, is this me generating a bad instruction? No, because I see them all over the place. This is some GDB thing. What the hell is RIZ? Yeah, no jobs. I forgot to put no jobs in, but for the purposes of what I'm doing right now, it probably doesn't matter, no jobs or not. No, dude, I already talked about why diff is not the thing. It's like, look, I literally have never diffed executables, so it is folly to expect that the first time you decide to diff executables, that they would be the same, all else being equal. No, that's not how that works. BIZ is a pseudo register that just evaluates the 0 at all times. Then why is it in there? Why is the assembly so different, which is uh, what I'm worried about. Okay, so once again, it's probably an invalid address, right? Like that doesn't look good. That looks like a valid address with junk in the high bits. Mm-hmm. Mm-hmm. I wonder if when it was in RDI, if I had printed that. I don't know why it was in RDI before and it's RCX now. Because if this is, wait, was this x64 backend? Because x64 backend should generate exactly the same frickin' instruction all the time. Like this, yeah, this is x64 because we have our no op in here. So like why, like what? How, what? That's another mystery. You may want to enable real register names. What does that mean? Is it not telling me the real register names? Like in the x64 backend, I mean, the problem is what comes right before this. I can't put anything in this instruction because this isn't the one that has the problem. Probably emitting a weird form of the mod rm sib byte. No. Well, I mean, maybe, but that's not the bug. And when we looked at the code a minute ago, it didn't look like this. So like this is just GDB being whack. Stop suggesting binary diffing the compilation or the decompilation. It's totally different than it was before. Okay, so I am very sus in several ways here. So see, when we generate this instruction, it's always RAX RDI. So like I don't know what's this RCX right here. That is really worrying me. Like someone said I should probably turn on real register names. Is this uh, like what? Okay, that's not anything to do. So this looks like my bug, but um, and this would affect both backends, right? But I don't understand why that's in RCX. Like what? Like is somebody renaming registers? Enable ATT syntax and see how it looks there. We were in AT&T syntax. I mean, same. So like I have no explanation for why this is RCX, by the way. Unless we are crashing at a different place in the program, at a different instruction that is exhibiting a similar bug. Which we are. We're in a totally different function, actually, guys. I don't know why I didn't notice that, except that I have too much going on. So it's very weird though. Like this could be a completely different bug, honestly. Um, this looks like a classic x64 backend bug that is different. This looks like a thing where we loaded something and we're loading it as 8 bytes when we should load it as 4 bytes or whatever. So this might be why it's so confusing, is that I was trying to debug this other bug and got bit by this thing, which, if it exists, I don't know why I'm not seeing this on Windows, because I should, because this would all be the same on both platforms. Okay, that's why it's RCX, and that's why the code looks different, because it is different. All right, so this is array add, which we can look at here, so to be faster. Array add, we don't really know which overload it is. Um, we see maybe grow, right? So it's probably this one, because these guys don't call that, although they could like inline or something, I guess. Except we don't inline in the x64 backend. All right, let's switch back to, now that I'm less confused. All right, so um, well, we call maybe grow, that's fine. And then, although this happens after like some multiplies and stuff, so I don't know what really is going on. Um, are we calling initializer or memset? Memset I turn into like rep stasb, so that is not bad, or not the worst. Um, I wish I could tell which function this was without going on a rat hole of like adding debug data to the thing. Yeah, double bug is when things are super confusing. That's when that's when you got problems. Double bugs. I mean, does this happen on Windows and I just didn't try it enough, right? Let's try it on Windows a bit. That won't jeopardize anything that we're doing right now. Let's make sure the compiler is up to date. Oh, it's Windows. How do I tell if it crashes on Windows? Kind of looks like it's crashing. It isn't. We'll do this just to, but we'll no check in it because we don't want to merge conflict between the same thing twice. It's not fun. This is very weird because, in the x64 backend, we do generate the same assembly. It could just be, though, that for whatever reason, due to calling convention differences or something, we don't have zeros in the upper bits or something. Or this is like a super rare bug. I mean, I could implement some crazy debugging information right now that just puts strings into the string table and loads them into RAX all the time, you know, and then you just see all these addresses in the source code. We actually could do that. I mean, when you have to debug, you have to debug. Yeah, the relocation table bug has been fixed. Really, I thought we were going to be ready to ship the beta, but there's still a couple problems, and we want quality. We want quality for the people. Oh, right, we know where we are. Duh. I'm not quite sure why the disassembly looks as it does. I'm a little confused about that. We may need to look into that at some point. Because, like, why is there all this stuff before calling the function? Like, what's this? Oh, that's okay. Never mind, guys. All this stuff, this is the stack trace nodes are turned on by default in a debug build. This is like stack trace node. This is the hash for the stack trace node and all this stuff. Okay, I am no longer confused. So we have that stuff. We have maybe grow. It's actually very simple. We call maybe grow, we get back. Of course, it's way too many instructions, but it's super debug. We don't care. Um, we're IMOLing, right? So that's, whoops. How do I list at the program? How do I reset the list to the program counter? I mean, I think it's this one, but anyway. So this indexing the array is that's where this mul is, right? We get the count, we multiply times 8, right? Again, this is very inefficient instruction encoding, but we multiply by 8 um, because we know at compile time that's the size of the element type. Um, we add that to the base data pointer, right? And then that's in RCX. Hmm. So that's weird. Okay. Was it 0x90 that we put RAX into, right? Now that's where we got RCX from very inefficiently 2 instructions later. But so if we look in this memory location, we should see, yes, this data with the one set that we do not want to be set. Why? Where did the one come from? Well, it was in RCX, right? So let's print these out, 88 and 78. Those are both RSP, right? I should start using the base pointer. 78. Okay, 78 is already jacked. So where does that come from? This is element 0, by the way. So we're multiplying 8 by 0, storing that in 0, and then getting the 0 back 2 instructions later. Like, instruction encoding on this back end is positively brilliant. Um, so, okay, we come back from this function. Well, no, let's keep going backwards. Let's not get ahead of ourselves. So who goes into 7.8? RCX here. 6.8. Let's print that. Okay. And then that is an address of something, right? So we read this, and then we read that plus 8 and dereference that, which is RSP plus, oh no, sorry. Yeah. Um, right? Read that. There's our value. It's already bad. So it's already bad by then. Where does that come from? This is one time where if I had worked on making the code generation just a little bit better, there'd be way fewer steps here, right? All right, where even were we? We were here. So now the question is, where does that address come from? That comes from the frickin' parameter, right? Is this a, Okay, what is going on, people? The reason I'm not switching back to Windows is because I don't know if we're going to be able to repro this bug anywhere else. Like, this might be a very rare bug, the only purpose of which was to stop us from debugging the other bug. But when that happens, if it's a very hard to repro bug, you would much rather solve it than like try to get it to happen again and then give up, right? Interesting. Okay, so I want to say, can I see what array is? No, I can't. Um, okay, but this is the data pointer, and the count pointer is one before it. Okay, so this is an array. It has 0 elements, but the data pointer is not 0, which is fishy. Oh, it's in the new struct printing. Oh, so we have this. Oh, interesting. It's already screwed up here. Oh, we call array reserve. See, we don't have the debugging for the parameters right now for some reason. Um, let's go up. Okay. So this thing has 10 members. So going back down, we should have done a reserve on printable members for 10 things, right? Yes, which it is. So now that at that time should have set this data pointer to be the right size. So the question is, could anything have modified that data pointer after that? Probably not. So I think the bug is in array reserve, which is then going to be pretty difficult um, because we've returned from that, right? We can't like step through it. We could do something like right before array reserve, just put total spam into the count, or just put -1 into the count. And then if it doesn't Like that would be equivalent. Like this might be working because there's usually zeros in the upper bits, right? So it is tempting. Actually, I can do this on Windows, right? In the Windows version, because if it's a code generation bug, it'll be the same on both platforms. We're going to say printable members dot count. Wait, it's the data pointer. Dot. Well, we'll make -1 printable. Oh no, we can't because that doesn't change that. Data equals. Oh, but array reserve. Ugh. See, array reserve probably checks if data is null, so we can't just do that. I mean, we should be able to verify that all this happened, right? The allocator is temporary allocator. Allocator data is null, which it should be. Allocated. And then even this, right? Even this looks correct. It's just that. Do I trust realloc? Not really. Not really. This is a weird thing where this is one of our few, for some reason, we still are using the allocators in libc. Just because I haven't gotten around to replacing that. Um, I don't really, so this kind of x64 bug where top bits get garbage in them typically happened. Um, oh no, guys, I know what it is. Guys, guys, okay, I know. Oh wait, this is printable members. Never mind, this is on the stack. That's just very fishy. just a very fishy number to be there where we don't want it. Hmm. So, like, okay, this is in the print function right now, right? The language is print function. 65536 is the size of um, the bucket size on the string builder. Oh no, it's not. Never mind. It's only 16. Um, but that, so if somebody after this allocation happened incorrectly wrote a 65536 somewhere, or I mean, maybe this is a bug in, okay, so this is weird because we're doing temporary allocator, but we're calling resize. Maybe I just broke that. If we temporary allocator with a resize, we're supposed to just go through and, I mean, this should be fine, right? Well, there's a lie in there. Oh, come on. Oh, it's print context-based temporary storage. Okay. Whoa. The temporary storage's data is corrupted. Oh, because this is the thread example, and the thread example creates temporary storages. Okay, this looked to me, I mean, it still might ultimately be this, but this looked to me like something, you know, there used to be a thing where in the x64 code generator, like, hey, we write something as 4 bytes and then read it later as 8 for some buggy reason, and you pull in garbage off the stack, right? That is what this looked like, but this is just like temporary storage is effed. Maybe I should have just looked much more carefully at the stack, right? Up, 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 up. God, we can't, if it's ever an argument, can't print it for some reason. What? Oh, star thread, not print. Whoa, okay. So print thread starting context-based temporary storage. Okay, that one is correct. Wait, it's the main threads. Okay. Okay, guys. It's the main threads temporary storage that is messed up. Do you know what is interesting about that? It is quite possibly at address 0 of the data segment. It could be that whatever ends up at address 0 of the data segment gets effed. So I'll show you where this is. This is why you have to know your system to debug. First thread content. Actually, it's not at offset 0 exactly, or it could be because these don't necessarily get ordered this way. But it's a global variable that we assign to on startup, and it's very early in the data segment probably. Let's see what the address is. It's 8 bytes in, probably. And that is messed up. So somebody is writing to that memory. Um, uh, yep, yep. So now this is very, very fishy, all right, because the crashes we were getting about the thread index happened when the thread index was at the global database. So what I think is happening is maybe the atomics, actually no. Guys, I don't know. There's some kind of bug. There's some kind of bug. That's what I think is happening. Okay. Um, so what is in the 8 bytes before that? That's probably the next thread index, right? Yes. Oh, guys, do the atomics. Let me think about this. So nobody should ever be modifying that except for the running thread. No, guys. Okay. This Let's talk about atomics because does anyone know if there's something funny about them on Windows? So like this this is 8 bytes away from something that we're using an atomic add with, right? And coincidentally, garbage is ending up there. However, garbage is actually ending up in the high bits, which this is a low endian machine, right? So the next 8 bits are seemingly fine, and then the 8 after that are getting stomped, right? Um, when you do atomics, it operates at a cache line level. So you could be writing back data. This is potentially brain breaking. Search for to do and check in bug. What are you talking about? 65536 is 10000. Yep, I know that. So it's a question of how false sharing affects atomics. Yes, and is it different between Windows and Linux in some way? And does that explain why the bug went away when we put that thing inside a struct? Because that struct was at least 16 bytes. And okay, hold on though, right? Because this is too much of a weird coincidence. It seemed like I was generating buggy addresses for for that other variable, but I never verified that, I don't think. They just looked weird sometimes, but maybe they're weird due to ASLR sometimes. Although large negative numbers is probably wrong. Um, but like it was crashing on the atomic before, probably with an invalid address. Does that mean that actually this is not really false sharing? It's also an invalid address. It's just that the invalid address is 0, right? And that somebody else thinks they're 0 also. I think the biggest difference would be the scheduler. Yeah, I mean, that's the thing is the cache hardware is obviously exactly the same, but um, there might be some cache configuration that's different. I don't know. I don't know anything about the degree of configurability of caches on these systems. Or to what degree this is faked by WSL and WSL is just doing it wrong. Like, is that a possibility that WSL is just doing this wrong somehow? It's like not doing cache coherency correctly. That wouldn't explain why the address was whack, though. Okay, here's the thing. Because this version crashes 100% of the time. Oh, that's actually also convinces me that it's not WSL's fault. Um, it's not quite, yeah. So I can just copy this executable, right? Okay, so I can rebuild and we're not worried about losing that version of the executable. Although, is all the debug execute info in the executable or is there something like PDB on Linux? I don't think so. Dude, why do I have so much trouble with this? Yeah, okay. I may do an assembly comparison between the Windows version and the Linux version to see if there's any notable difference. That is not, no, that is not where I'm at right now. Why do you guys keep suggesting variants of the same thing? You're just gonna make me annoyed and not want to stream. Something not declared volatile. This is a totally different language. It's not how this works. The really weird thing is, there should not be. So if watch points worked, see, this is the interesting thing, is we know that this starts out correct, or at least I assume it does. Like, I assume that on program entry it's correct. So since we know what is getting corrupted, we could break, if we had frickin' watch points that functioned on this piece of crap, we could break when that memory changes if we had a working debugger, and we don't, unfortunately. Although, I guess it was, no, I did a direct memory watch last time and it didn't work. We could try it again. Okay, so we're here, and we are going to print. See, that data pointer is fine. And then we're going to continue. Still fine. Oh, wait. Hold on. I don't know how this works. No, it's not fine. Okay, so printing $1 actually prints by value, the same value, not the expression. Okay, that's fine. So see, this was 283040. Now it's 283040 with some stuff in the high bits. So if I could just data breakpoint that shit, then we would know what the problem is. So we will try. Okay. So wait, what? Did we like Heisen our memory right? Hold on. No, that still happened. Okay, wait. What? What is happening? Okay, this is inside a thread. We have an entry proc. This should have set the temporary storage on the frickin' thread. Guys, that's how this works. Starting temporary storage, blah, blah, blah. Okay. I wonder if it just doesn't set this correctly because it is a different. This could be, well, I don't know. Let's see. This GDB thing is terrible. Uh, Thread. So this is not setting the temporary storage. Like that just didn't get ported. Make this the same. Wait, this isn't either. Starting storage. Okay. Hold on. Squeeze me? Okay, so the thread's not started theoretically. Okay. Okay, so this is very weird. Let's look at what the program is doing. So we call this thread proc and it just asserts. Temporary storage size, also 16384. Hmm. Wait, what? Okay, hold on. Hold on, guys. Temporary stooge. Okay. If you pass a starting storage, we copy everything over. Otherwise, we call alloc on the temporary storage size. We set the size, we set the occupied and the high water mark and the original data and the data. I haven't thought about this in a while. But supposedly we set this right here, so it's not null. So the all I'm wondering is if somehow if we create the thread and on Linux it's started when we create it, then there would be a data race, right? And we would be in the middle of initializing these things and they wouldn't be set. That wouldn't explain the other weird stuff with the addresses though, which is still pretty whack. But like I'm kind of not, I don't have a good explanation. I don't like how much code this is. I don't like p threads. I don't think they're good, but like I don't know why we need a giant entry proc that goes for 17 days. So if this doesn't work on WSL, then we start using this stuff before it's initialized. So the question is there pthread jankiness on WSL in some way? But no, that still wouldn't explain the other problems. I feel like there are two bugs here, and maybe one of them is not my fault, and it's making it hard to debug the one that is my fault. Dude, I'm gonna start banning people who tell me to invest in an environment, okay? Yeah, I don't use the Linux GUIs because they're terrible. They're worse than straight GDB. Like, why would I use them? All right. Like, at least GDB doesn't have its UI hang all the time and be like slow and fail to refresh and like yeah, it's bad, but it's not that bad. Or like fail to open the window to begin with because of different GNOME KDE versions. Yeah, I feel like there are two problems. But again, this is very weird. Okay, I think my current operating theory is that trying to set that global watch point screwed up WSL and or GDB in some way and caused this thing that we're seeing now. I don't think this is a real bug because it only started when I started trying to set this watch point. Let's see if it does it consistently though. Yeah, that's very fishy, guys. Well, let's see. Let's see. Let's delete 3, run. No, Now it's just happening here 100% of the time. Run. Delete one, run. This is so weird. The temporary storage is null. Okay, if I want to determine if this is due to the thread starting early, I can set the temporary storage pointer to something totally whack. That said, I don't know why this is happening in this order, but okay. So here, let's get rid of any weird modifications. That might take 30 seconds. Restore. I can restart the WSL process. Why is that going to matter? Yeah. So here when we say thread init, this looks like such a mess, dude. Okay. So the thing is, we create the thread, we set the proc later. So before pthread create, but then we don't even have like starting context. I don't know. Wait, starting context. I mean, hold on. Wait, this never gets set. Oh yeah, it does right there. There needs to be a blank line here. This doesn't look that much like a data race to me. Because it would have to be between here and here, which it could be. I mean, we could just do this. I mean, now we get to have fun with this not crashing for a year. Oh, there we go. Oh. Okay, well now we're back crashing here. If we run again, we're back crashing here. If we run again, we're back. We run again, we're back crashing here. Now we're going to break program main, run, we're at main, continue. Okay, crashing same place. Run, main, continue, crashing same place. Okay, so now run, print starting temporary storage. What's it called? First thread temporary storage. Okay. Now we're going to watch. Right? And then we're going to go. Okay. So that time, it didn't happen. Let's look at the instruction. Wait, what was it called? How do you set the disassembly flavor? Oh, I didn't save it here. Okay. Okay. So that is a totally whack address. Now that's weird because, again, we think the address of the variable is fine. So when we output the instruction, maybe it's not initialized, but then it gets initialized. Like, no, that shouldn't be able to happen. Should not be possible. Yeah. So RDI does not look like a simple number with junk in the high bits, interestingly. Okay. Okay, RDI comes from RSP plus 368. Okay, see this right here? This is the garbage. Um, I'm actually not sure. I could definitely set a breakpoint watching for that. It's just, it's an add 64 immediate. Just trying to figure out. It's not that one. It's not that one. And it's probably this one. Oh, it's the offset field of a pointer constant, right? Um, wait, what? What's that called? PL globe. What? Oh, it's in bytecode builder. PL global symbol. Okay. Integer add to constant. Okay. So this is corrupted sometimes. Oh, that okay, guys. I'm so stupid. Um, remember the other day when I was on the stream and I said this looks like a compiler bug, so I'm going to put in a workaround? Yeah, well, later after I had a couple days of annoyance fixing all these other bugs with the ELF files and stuff, I looked back at that and said, I, you know, wait, what? What am I even doing? I'm so tired. Um, I took it out because I theorized that that wasn't really a compiler bug. I bet it is. Or at least it's like undefined behavior that's undefined in a way that I don't understand. Um, it was in copy literal. In fact, I actually took it out in its own check-in. This, remove unnecessary workaround. I think this was my death that wasted a large portion of these few hours. So this was this thing. So to review, this values is a union. And if you copy a struct containing a union to another struct, it should just copy the whole thing. But like putting this in maybe fixed something, even though it should not, as far as I know. Right? So Oh, we're actually, values is the union, so we're copying the union, but then, like, if it's pointer literal, I'm explicitly copying the pointer literal info. We'll see if that makes a difference. Like, again, if it does, I can go back and take a look at it and see if I can come up with any explanation why it should matter. Maybe there's a warning among all this garbage that I can't figure out how to turn off that is telling me that it doesn't like what I'm doing. I don't know. Um, so, yeah, we're just doing. So now the question is that assert right? I'm actually not sure. It might be correct. In which case, if it's correct, it's catching our problem, and that didn't fix it, which it's good if that didn't fix it actually, because it doesn't make sense to me. Okay. No crash, no crash, yes crash. Okay, so it only happens sometimes. So this is actually good. Yes, okay, this is fine. I'm okay with this. This has nothing to do with the other things that I was flailing on. But maybe it's all connected somewhere. I mean, it all has to do with the same couple instructions, so I don't see how it's not connected, honestly. Okay, so sometimes we get a massively negative offset that's like a corrupted value in this variable. This was the same thing I was stepping through a few days ago, right? If I print the literal, I mean, this is a big spam, but print literal values dot pointer literal info. Okay, see this offset from symbol? That is what we're reading, and we're actually casting that down to S32, but it's still turning into a negative number that's pretty big. This is obviously garbage. This is supposed to be an offset in bytes into an array that I have in memory of data. So like, that is not the thing. That is not the play. Now, this does come from copy literal, last I checked. So we could assert that offset from symbol. It might be something down here is messing it up. Assert result pointer literal values pointer literal info dot it's just very suspicious that it's just the last member, right? This is the pointer literal info. This has another union in it, and then this, right? I'm actually not sure if greater than or equal to 0 is right, but if it's not, we can make it greater than some mildly negative number. It's literally the same problem. Okay, still happening. Inconsistently, which means that that's probably the right thing. God damn it, dude. I want to do the ARGS thing, but I'm gonna have to because everything else is terrible. Okay. Wait. Okay, see? Somebody else stomped the memory. This is again, I need data breakpoints because we asserted that it was greater than or equal to 0. That didn't go off. but later it did. Dude, without data breakpoints, I can't program. So I might have to just set up a VM because this WSL thing is probably the cause of them not working and is therefore garbage. Do data breakpoints supposedly work on WSL2 if I try to upgrade to that? The problem, of course, okay, so the problem with upgrading to WSL2 is I could ship a beta right now, approximately. Okay. Um, if I destroy my environment that will let me ship the beta to do something else, I lose my ability to ship a beta tonight or anytime soon. I might just go to bed before that because even if I fix this on this stream, it's like probably a bit of a rushed beta. You know what I'm saying? Hmm. Hmm. So it's not the copy, which again, I guess I'm glad that it's not the copy because uh, we don't want it to be a weird compiler bug. We would rather it be our program doing something wrong. Okay, so this is a 16-byte offset from pointer literal info, right? We were looking at this before, which would put it I mean, inside this union, right? But if this wasn't the right size for some stupid bug reason, then this would have overwritten it probably, and that's why I put this, or sorry, this assertion after the thing. If assertions even work, which again, wait, yeah, I don't know. Let's double check. Let's make sure that we built after that. Oh, wait, I'm not running it. Oh no, I am. Okay. Yeah, like it's always in the same place. So somebody is stomping this memory. We need to update Windows to the March 2020 update. I do believe that I already updated that. I don't know what is the right way to check, but it should be on the newest. It took like 2 hours to do the update. It was crazy. Um, I need a data breakpoint, guys. Okay, what I could do is I could try putting this assert in the Windows version. The bytecode builder one. Because then I would be able to actually debug. Let's find out. Oh, except okay, what are we running here? Wait, it was 250 there and 250 there. This is really, oh God, that's a totally different problem. That's fine though, randomize. Dude, picking random numbers from the timer is totally broken. Holy cow. Okay, anyway. I just want this. Get rid of our breakpoints. Didn't happen. Or the assert didn't go. Assert didn't go. Didn't go. I mean, it's probably not going to happen on Windows, guys. Install a second WSL distribution. I mean, that's not, so somebody was saying the other day on the stream that you upgrade WSL itself to WSL2, right? I mean, if that's not how it works, then maybe it's fine, but like, do I have any faith that that's not going to break the other thing? No, that random number is actually one that I pick based on getting the current time. You'll also notice sometimes when I run the compiler here, uh, not here, but in Linux, it reports that like no time has gone by. See this? Like our front end time is 0.1 seconds, and then everything else is magically 0, right? It's like the timer is running on a software interrupt generated by the multimedia timer or something, you know? It's like total garbage. Yeah, it will probably just frustrate me. Yeah. Um, does if I'm not going to do this tonight, but if tomorrow I were to go install a fresh image on VirtualBox and remember how to do all that again, do hardware watch points work there, or am I screwed? Like, do I need to debug this on one of my servers? Which I could do. I just kind of don't want to deal with that randomness. But like, we have like 4 different Linux servers that we co-locate that I could do stuff on. So the problem that I have is this particular memory corruption is not happening on the Windows build, but it is important to fix. So, well, let me put it, it is not exhibiting in an obvious way on the Windows build. It may actually be happening and just hitting something that is innocuous. It may not be happening. Um, this might be a bug due to WSL in some way and not my fault still, right? Because I've only ever seen this on WSL. I think the answer is that I have to use one of the servers tomorrow. Because then I'm actually on hardware. No, this is WSL1. There's no question. I know it's WSL1. Like, well, like I installed it the other day. Use watch points in VM in Windows. Okay, so maybe I'll do that. Because the thing that's better about working in a VM is again, I can like mount the file system and still have access to the same files and stuff. Although I can't really mount it in the other direction the way we did with WSL here, but it's still better. Maybe not. Maybe not. WSL requires Hyper-V and you don't already have Hyper-V installed, your other virtualization programs may not work. You know, I think I did install Hyper-V. So like if that breaks VirtualBox, then I'm in for more fun. Do I have a Linux server? I just got done saying I have 4. I literally just said that. Uh, um, if you have Hyper-V set, then you'll need to turn it off to run virtual. Should I just use Hyper-V? Like, can I just run a VM in this? Is that better than VirtualBox? The reason I installed it was because like maybe it's better. But I've never used it before, so I get to like figure all that out, right? Certainly doesn't seem better. I don't want to connect to a server. All right. Virtual machines, new, whatever. Yeah, I could figure all this out. Watch points should work in WSA with Valve. What are you talking about Valgrind for? When did that? No, just no. You guys are. I don't understand why people put up with and think is normal the things that they think are normal. Like in a debugger, you should just be able to set a data breakpoint. That is just a thing. You shouldn't have to jump through hoops upside down, backwards on fire to do that, right? And so that's a reason to either. So basically, we're saying WSL is not viable. I guess that's what I learned, right? Um, there's some good things about it, like it's very easy to access the files. WSL1 is not viable for shipping betas on simply because I can't debug on it. If I can't do data breakpoints, I can't debug. So the question is, does anyone know if data breakpoints work in WSL2, or should I not bother with that either? Because at this point, since I've accepted that I'm not going to be shipping betas on WSL1, if I delay this one by accidentally destroying it by trying to update to WSL2, that's maybe not as bad now, right? WSL2 is a virtualized kernel. Theoretically, it should work. Well, you know what? Let's give it a try. Update to WSL2. I'm looking for the text you just said was on the page. Why do they always say PowerShell, by the way? All right. I guess I didn't do enough steps. The Linux kernel update package. Oh, I already downloaded that. If this requires a reboot, then rip stream. Look at this, I downloaded it a week ago. That's how far ahead I was thinking. Okay, well, maybe that was fine. Maybe I didn't do all these other steps. Oh, I skipped this. No, this is just update Windows 10. We already did that. Version 2004, 1904-1508. Wait, that's fine. It's this. We're way higher than that. Okay, so this is fine. Enable virtual machine feature. I think I already did this one. Pretty sure I did, but maybe not. Does this mean it's actually installed? I don't actually know. I mean, it's not erroring, so maybe this is fine. Well, let's see. So wait, when I say get off the, like, is this running it in a different WSL? Do I need to stop my WSL once? All right. It's how bad is it that I had a shell open on that? Dude, I typed WSL-L-V like 5 times in the past 10 minutes. I don't understand Twitch chat. I literally just typed that. It's on the screen from last time I typed it. However, thanks, because if I didn't know that, that would have been helpful. But I did. All right, well, we'll find out. Like, okay, does anyone know how long this takes? Is it like an hour or is it like 5 minutes? Because I could just go to bed and wake up tomorrow and say, it's like waking up for Christmas to find out what Christmas present you got, except we find out if we destroyed our computer or not. It's instant. I wouldn't call this instant. You have a funny definition of instant. Let's screw this up even more by exiting these. Oh, it terminated. You're terminated. Wait, did I type that right? No, I keep missing. All right. So if I just do this, all right, this is the right one. Let's see what happens. Um, all right. Well, history doesn't have my actual history. It's got like the other shell history. That's fine. Test, language test, standard. Oh, it's faster. It feels, the autocomplete feels snappier. Um, I can't control D to get autocomplete. Temporary storage and context. Okay, so this is good. We're getting our assertion, at least sometimes. This is good. This is what we wanted. It's working much better than I had hoped so far. Oh, and it's doing this regardless of x64 or not, which is great. Okay, great. So now, um, okay, 60/20. Oh, but we didn't run with no jobs. So let's keep running with no jobs until it crashes, which hopefully it does. Please. Oh gosh. Come on, guys. Ugh. Well, we warmed the CPU up. Oh, there we go. Okay, if it doesn't happen with no jobs, that's going to be harder to compile. We can still do it, but I prefer with no jobs. Not happening though. Okay. Okay. So the serial number is not going to be the same, but the line number for the literal is going to be the same. Well, right. I hope. Maybe not. Actually, last time we saw this, it was happening in different places. Let's see. Let's try again. So if this is consistent, right, then we could set a breakpoint on that. Let's try one more time. Okay. Up. All right. So instead of trying to get too fancy, I'm just going to bake this right into the program. Okay. I don't know what's going to happen to our files here. Uh, I'm just doing a file visit to make sure. I don't know if it's WSL $$ or WSL2 $. Guess we could have done this. Not that. All right. It's WSL with $1 now. Okay, well, let me just see if I do this and then I make, yeah, okay. So that's working, great. It's science. Science, okay. Um, so I'm gonna do this in copy literal, because I think this, I'm actually not sure because I remember observing this last time we debugged and the problem could have been different then. But I think I remember seeing in copy literal, So let's just try this. C++, making everything fun. Strings match. C++. All right. So let's just make sure it crashes before we try to break. Nope. We've totally destroyed our arguments now. Can't see anything. Okay, good. Good, good, good. So now we're going to break here and keep going. Okay, that's not promising. We're never hitting this breakpoint. I feel like the file name part, or actually, maybe this isn't coming from copy literal. The problem is, because we can't run with no jobs to repro this, I don't have a serial number. I need somewhere else to break. Okay, so this is a literal, it's a pointer literal. I think those mainly get made in one place. PL global symbol, etc. I think three places. No, commented out, not commented out, not commented out. But we can break in make pointer literal. Actually, this is good. We know which one because this is line 166 of thread. That's going to be a unary operator. Right there, it's this. So basically the address of a variable, that's a pointer literal, a global variable. So that is going to be this one. So we could actually go here. That doesn't. So the problem is we could set a breakpoint here, but maybe that's not the same actual one because it could get copied or something, but we'll try. And this is rare enough that we should just be able to say line 166 and it should be the only one. just wanted to get this actually. That's fine. So it's still happening. So now we break. No, there. Okay, fine. Now, I just want to see if this is the same one. I don't want to try to set the breakpoint yet. I just want to know. Actually, we just want the address probably. And this. All right, continue. Didn't crash. Just keep doing it till we get the crash. Continue. Didn't crash. Didn't crash. Of course. Okay, that's good. All right, so up. Print literal. It is the same one. That is good. Okay. So what we can do is we can put an assert here. It's called offset from symbol. Okay, we're just going to put that there and remake, because if that goes off, it saves us a huge amount of trouble. So now I just want to know, is it the new assert or the old assert? Wait, really? It's this easy. Okay, this is something about the thing is not getting totally initialized because it's in a union. This is like a compiler diff. Okay, I get what's going on. I should have thought of this before. Wait, no. 8744. Oh, because I added things. Make pointer literal. See, we do not, this is old debug code. We do not set the offset because it should be in the initializer. All right, like this is initialized, but because this is inside a union, it's maybe not getting initialized, except that it should be getting set to 0 because of frickin' this. Now the question is there a warning being issued about this that I can't see because it's, and actually there is, right? So what's happening is it's not setting that to 0 because it's inside some unions or something, and because this isn't a very good programming language. So I should have actually known this. I knew this was an issue. It's just I have so much to think about that I forget. All right, I bet it's fixed. I bet we can run this a lot of times. We'll run the x64 just because that's what we've been doing, but it was in both. Look, everybody. Okay, so that was actually a lot easier. I started tracking this down like it was going to be a thread Heisenbug, which is why I didn't just go there. If I thought this was just a regular uninitialized variable, I would have just jumped straight here and it would have been like a couple minutes. The problem is I was assuming that it was going to be like that weird stuff that we looked at under WSL1, which by the way, you'll note is also no longer happening, um, about uh, things getting set later, which is why I wanted the data breakpoints. We didn't need data breakpoints for this because the initial value was incorrect. So this was very easy. It's just I was, after several hours of grinding on something that may not even be my fault, um, I was just going in grindy, and this was not grindy at all. This was just like, well, GG's. When a union is initialized by aggregate initialization, only its first non-static data member is initialized. Well, we could put the first one, the biggest one first. That's the worst idea. I mean, I understand why. It's because if you have non-zero initializers, how do you know which one to set? But still, it's bad. So we could put the biggest one first. Because these are all actually zero, right? We actually just want zero for all of these. Um, like literally, we just want mem set it to zero. And I used to do this, and then it was complaining about that, so I did that. I don't know. I don't know what those mean, honestly. Okay. Anyway, so we're going to take for granted that we can't actually use this initializer, right? Um, so let's go back to that for a second. I got loose. I didn't put a no check in there. That's not good. Okay, we do have one here though. Let's get rid of this, and let's get rid of this, and okay. So where was make pointer literal? Typer. Okay. Pointer literal type. Okay. I just opened the header file by hitting a shortcut. So, I just act. I, what? Why? Emacs is so random. Okay. So we set the value type. Dot generic expression pointer equals null. should get over my collar, clearing this just to be paranoid. Did I get them all? Where's the error? Where's the error in all the there it is. Oh, I forgot to say values dot. Dude, some of the features that I'm used to from the new language are so much better than this. All right. Now, the whole reason we were doing all this was because the tests were failing sometimes on that one test. Now, because we never got past that test, who knows if there's another test that was failing. Let's go to changelog. Fixed a crash bug due to pointer literals not being correctly initialized on Linux. Also possibly on Windows, but didn't exhibit there in an obvious way. Okay, great. Oh, is that because of the thread changes that I made? Why are we hanging? What did I do here? I don't like that we're hanging on this. But yeah, this has thread stoppage. I really should just revert. I don't remember doing anything important there, although who knows? This is actually before the one that was crashing before, I think. Okay. Yeah, maybe I just broke that with, I'm going to say I broke that with my haphazard editing of the thread module. Why are people spreading lies about imgui? There is no way to define what widget gets focus when you press tab. That is false. That is false. That is not a fundamental limitation of imgui. That is completely false. Falsehoods are being stated. I do not like it. Wait, I meant to do this. Look at that, they're passing. They're passing. You need to have a stored concept of a widget to get. Like, I've said this, debating it in comments is impossible. Well, look, it's been a while, but I've said this on stream many times, right? ImGUI, and you can talk to Casey about this because he invented it. ImGUI is about the API to the program. It's not about internal state that is kept behind the scenes, right? So if you want even just very basic visual polish, like, oh, I moved my cursor off this button. So the button was in an excited state, it was like glowing, and now it's going to like deglow slowly over time after I move my cursor off it. To do anything like that, you have to have some state behind the scenes where you remember that that button was a thing, right? That's still ImGUI. What makes it ImGUI is that the client code does not have to construct a button and manage it as an object, right? It just tells you every frame that it wants to do a button, right? It's a different thing. So how do we identify these things in ImGUI systems? Well, as conveniently as possible. So usually you use file and line, for example, right? Or just you pass a pointer as like, this is my, you know, like often when we identify widgets, it'll be like pointer and then index, where the pointer is just any random unique thing you have lying around that associates with, usually like if I'm going to draw a panel full of buttons, I probably have a data structure, at least for the panel in my own program, and then that becomes the pointer. Casey doesn't want to talk about it anymore. Well, I'm sure, because I would be grumpy about it too if everybody kept not listening to what I was saying. What do I mean? I'm already that grumpy when people don't listen to what I'm saying, but it's just about other things than in GUI. All right, this is great. Um, this is great. We can ship the beta. So I wanted to do some Let's documenting, but it's too late at night to do that. So we're just going to ship it. Let's make sure, because I've been editing files on both sides. Let's see if we can even commit. I'm sure I've left a no check-in, but fix pointer global initialization. That's not even the right thing. Why is this taking so long? Do I have networking on WSL2? Oh, dude, don't tell me I don't have a network. Ah, ha, ha, ha. What is my password here? I don't even want you to know how many characters it is. You know it's at least 5. Although I streamed that the other day. Hey, look, there's a no check-in. Temporary storage and context. Oh, that thing. All right. Great. Let's do it again. Okay. Great. Now, there's the Windows version, which I don't know what's modified there. Change log here. Okay, well, wait, why did I leave that 0? That's not good. I didn't. This thing claims, but this save. Oh, changes. Wait, is that the other? Wait, no. Oh, that's down here. lol. Wait, let's just revert that file. There's no reason to modify this because putting it first is not going to matter because we decided we're not going to depend on that and we're going to explicitly initialize. Yeah. All right. That's not going to hurt to have that assertion in there. That's fine. Except that we actually change that on the other machine. Okay, great. No, out of date. Danger, Will Robinson. Oh no. Oh, because I also did that offset on both machines. All right, hope I didn't totally destroy that. So I'm going to run full tests on Windows to make sure I didn't break that. But first, I'm going to go here. Built on October 10th. Has it really been a week since I shipped a beta? What? Dude, I was shipping them like one after the other. What happened? It's like been a week? I guess 6 days. Oh no, that's yesterday. Guys, I blink and it's been a week. I blink, just blink. It's been a week. Let's get a release going. Update. Version number for the beta. Update. Why did I decide I don't want you to know how many characters it is? Because it's just very annoying for me. All right. Make. And we're making debug build right now as well, right? So we need to run all those tests with a release compiler. One of these days I'll figure out all these errors. All right, so Windows is done. So we're gonna go build Sokoban. Wow, okay, it's chugging because of the WSL make. Interesting. It's probably just the console slowness from all those warnings. Okay, maybe people stop talking in chat, or maybe Twitch is broken. I have to put dots every once in a while. All right, this is great. This is a new level that I made. It's pretty awesome. Okay. Ow. So that runs. So we're going to hit that. We're going to go over here. All right. Going to run this here. Go back over here. Uh-oh. Okay, this is just an Emacs fart file, and we don't correctly ignore those. So I just have to manually delete it right now. Let's run this again. Run it back. And this one's going. I forgot to check the version. Great. Wait. I didn't save the file. I typoed it and then I fixed it, but I didn't save the file. Ugh. All right. We have to run the tests again. If you change the file, you gotta run it back. All right. No really update the version number. Update. And now we get to remake again with all our wonderful errors. This one is done. So we're going to do x64 version. Yummy, yummy. Yummy, yummy. Yummy, yummy. Well, we didn't get to Let's Document tonight, which I really had wanted to do because I thought this was going to be an easy beta ship. We had this last bug. This last bug turned into a lot. I still don't know what was happening with some of that stuff. Like definitely, so that pointer literal corruption explains the lock instruction crash that we were seeing, right? Because uh, it was, so that's actually another thing that when I first saw it, if I had been sharp and drinking my Ovaltine, I would have realized, oh, well, we had this problem the other day with pointer literals with like random offsets. So that must be what this is, right? Like I should have just thought of that as opposed to spending 2 hours trying to debug it and getting stuck in like other weird, probably WSL's fault stuff. Um, like that literally should have been like that. It's just, I have so much to think about these days that it's hard to have that kind of focus. But sometimes not having focus is expensive. Um, all right, cost me a couple hours probably. Should we judge me or is it all good? I mean, it's all good, but by all means, like the way that you get good is by observing both the mistakes you make and the mistakes other people make. Like I definitely watch what other people do and deliberately don't do that because I don't like their outcomes, right? So if you don't like my outcomes or if you think it could be better, don't do it the way that I do it sometimes. But the trick is some of the stuff I do that does not look good to you might actually be key parts of what works for me. And so like, how do you tell the difference? I don't know. All right. All right. Update. Oh, before we do that, Make sure the version. Yep, it's got the 29. Boom. All right, great. Oh, this is so good. I'm going to be very happy to have shipped this beta. x64, that's done. Update. Get the Linux binary over here. CD distribution. So that .exe is something that our build server made. So that's good that that's running. And this will, whoops, this will check that they match. Wasn't there a way to save your credentials? Yes, but you have to set up some keyring bullcrap that I don't have time for, especially because I'm going to wipe this image and go to Alpine Linux anyway. So like I'm not investing in configuring that Ubuntu, right? Because at minimum, if I stayed on Ubuntu, I would move to 20, right? But I don't. I want to like switch to Alpine, but that by itself is a whole project probably that could go badly for a while. So like I don't want to do it right now. Did I do an optimization pass recently? Not really. There have been some small optimizations, but no big ones. All right. Okay, that Windows version was old. Dang it. I should have checked it. Come on. Maybe our build machine isn't working, actually. Build passing 1104. Guys, what? Okay, I bet it just took it. I bet there's a problem with the build program. Let's go to there, build server. Checking in a new line. I can just build this locally if I want and ship that. It's fine, but I just want the build server to build it. I could hop in the Microsoft Store and just download Alpine. Spoken like someone who has no idea what the issues are going to be when I try to make the compiler actually run on that. Literally no idea. Like, for example, we link LLVM. How's that going to go? We're trying to make a statically linked thing. How's that going to go? Just download Alpine. Guess what? I already did. Downloads. Where is it? Oh, it doesn't go there. But I did download it. I'm pretty sure. Let's just play Minecraft. Oh, I didn't actually install it probably, but we did. We know that it's there. Oh, come on, build server. What is going on? We'll give it. It took it a I don't know. Is it taking like 10 minutes to do things? I don't know. There are lots of reasons to need a historical record of binaries, like because your binaries and your source are intimately tied together, because while you're developing a project, you're changing the file formats and stuff or the meanings of the various things. Like I add a field to an entity in the code and then I save them out. And now the entities have that, right? And so, and then you need to go back or forward builds. I need to run the build from last week to see what was happening or whatnot, or things are broken right now and people need to run the last week's build in order to be able to work. If you didn't save all the binaries exactly, you're screwed, right? Like you just can't, yeah. Like games are mostly data. This is the thing that people don't understand. There's a significant amount of source code, but they are mostly data. So if your version control system does not do well on mostly data, it's not a good version control system for games. That's just how it is. Come on. Yeah, yeah. All right. That took a while, but it happened. Yeah, the reason we want to do Alpine is because supposedly they've done work with muscle libc and stuff so that you can build a statically linked binary there that will work everywhere, which is what Linux should have done from the beginning, but they didn't, right? So assuming that that works, then we'll have a better version of the compiler that Linux people at least don't have to run in containers. Like right now, we have people who use the beta on Linux on distributions that are not Ubuntu, and they have to like run it in an Ubuntu container or whatever. And when you give people the compiler for the first time, that's like extra crud that they have to do, right? So getting rid of all that is what we want to do. Who knows though? Like the fact that we're linking LLVM and LLVM is freaking gigantic. I have no idea what that means in terms of building a static binary. Literally none. I don't know if Alpine, I assume Alpine probably has a precompiled LLVM, but it might be a different version than the one we're using. And if there's something that I've noticed, it's like every single time we change LLVM versions, there's a non-trivial amount of work to do, just remapping things. So it's not trivial at all. All right, everybody, um, we have the beta. So thanks for hanging out. We said a couple days ago we were going to ship the beta and did not succeed, but tonight we succeeded despite adversity. We did not let's documenting, but that's okay. We kept the beta train choo-chooing forward, and that is good. It's one step closer to making the beta bigger. Basically, I want to double the size of the beta soon. I'm just waiting for it to stabilize. Like we had these couple of builds down here where it was like, we did some stuff and it kind of broke some things, and then I didn't test Linux that well last time. So this is like a big crash fix build. Um, and then hopefully it's kind of stabilized for a bit, but we'll see. Yeah, I'm surprised at how well the WSL2 went. That could have been the end of the night, right? That upgrade, but instead, we're good. What's the timeline to get off LLVM? Like, that's not for a very long time. In fact, LLVM is probably an optional component through all the foreseeable future because you could use it to, to target platforms that we don't support yet, right? And that's useful. We'll see though. All right, thank you everybody, and we'll stream some more maybe tomorrow because um, we had post-hurricane weather. Like there was a hurricane in Louisiana, and then here where I am, we got the remnants of that today, I think, and it was very rainy. I think it's going to continue to be very rainy tomorrow. That's what the weather forecast said. So I may be inside a certain amount of the day. We'll see. Thanks, everybody.